Hi, welcome to the fifth video of topic 13 in Edexcel IT A2 lessons. So with this lesson, we conclude the entire topic 13 in your A2 syllabus. I also discuss a question from 2023 summer paper related to this lesson. So let's start. Okay, so here's an Edexcel syllabus related to this section 5 in topic 30. So in the lesson that covered lesson 4, we learned about encryption as well, but the focus of that lesson is to cover encryption related to storing data files and passwords. It's only a subsection of the science of encryption. So in this lesson, we talk about the complete usage of encryption, including encryption used in data transmission as well. So we will first discuss what encryption is, their main usages. Then we will discuss about the two types of encryption used, and then go deep into each of the encryption types by understanding the features and functionality of asymmetric and symmetric encryption. Finally, we will discuss about certificate-based encryption, what a certificate is, what a certification authority and a verification authority is, and what is a public key certificate is and its usage. Right. Okay, so starting with the definition, as always, encryption is the method by which information is converted into secret code that hides the information's true meaning. The science of encrypting and decrypting information is called cryptography. Encryption has long been used to protect sensitive information. Historically, it was used by militaries and governments. You must have heard about or seen movies about the infamous Enigma machine used by the Nazis during World War II. It's said to be the most advanced encryption device at that era to an extent the forces couldn't tap into any of the German communications. Finally, the British found an earlier version of the Enigma and they secretly cracked the code, giving them the ability to decrypt and listen to German messages that ultimately changed the war in favor of the Allied forces. So, there's a great movie that came out in 2014 called The Imitation Game. That talks all about how the British cracked the Enigma code. So, in modern times, encryption is used to protect data both at rest and also in motion. So, what is data at rest and what is data in motion? Well, data at rest is where any data element is stored in a computer or a storage device, maybe in a database, on a hard drive, in the cloud. So, where the stored data can be accessed electronically. So, how encryption is used in data files and password at rest is what we can use the lesson that we covered in the lesson that under 13.4. Data in motion is anything to do with data being moved or transmitted between two or more electronic devices over networks. For example, a password being transmitted from your browser to your bank's online banking server for verification is password data in motion. An important sensitive email being transmitted from your email client to the email exchange or from exchange to the recipient's email exchange is important data in motion. The data in motion is at a higher risk of hacking uh, than data at rest, since your data most likely to go through internet and through networks, so you don't control or knows like how secure they are. Okay, so encryption plays a vital role in securing different types of IT assets and personally identifiable information. To this end, encryption serves four essential functions: confidentiality, confidential like information fallen to the wrong hand will damage a business or a person. Financial information of a business or an email conversation of an important merger are a couple of examples. So therefore, encoding the data to prevent it from being understood if it is intercepted by and fall into wrong hands is the first function of encryption. And the second function is authentication. This is the function of encryption that verifies the origin of the data that has been encrypted. So, in other words, encryption guarantees to the receiver that the origin of the data is actually the sender that the data say it originated from. And then we have the integrity. It validates that the data has not been altered since it was encrypted. For an example, an invoice sent by a seller to the client may be altered to include a different bank account. Encryption makes sure such breaches to the whole data content or part of it cannot be done. And then we have non-reputation. Uh, it prevents senders from denying that sent the encrypted data. So this function is performed via what we call digital signatures. Uh, for an example, a buyer cannot uh, like an order they places through securely digitally signed channels after the goods were shipped to them. So this aspect is important, especially in business to business e-commerce, since buyer and seller may be located in different parts of the world and has never met physically. In encryption schemes, there are two techniques you can employ to ensure data security: symmetric encryption and asymmetric encryption. The primary difference between these two types of encryption is that with symmetric encryption, the message to be protected can be encrypted and decrypted using the same key. We call this key the shared key. In asymmetric encryption, requires the use of two separate keys, a public key and a private key. So, in this case, data can be encoded by the public key, whereas the data can be decoded by the primary key. So, in a simple world, like as you can guess, asymmetric encryption is more secure than the symmetric encryption. Symmetric encryption is a type of encryption key management solution where only one key, a secret key, is used to both encrypt and decrypt electronic data. The entities communicating via symmetric encryption must exchange the key so that it can be used in the decryption process. So, this encryption method differs from asymmetric encryption, where a pair of keys, like one public and one private, is used to encrypt and decrypt messages. So by using symmetric encryption algorithms, data is scrambled so that it can't be understood by anyone who doesn't possess the secret key to decrypt it. So once the intended recipient who possesses the key has the message, the algorithm reverse its action so that the message is returned to its original readable form. The secret key that the sender and recipient both use could be a specific password or a code, or it can be random string of letters or numbers that have been generated by a secure random number generator. There are two sides in an encrypted communication: the sender who encrypts the data and the recipient who decrypts the data. As the name implies, asymmetric encryption is different on each side. The sender and the recipient use two different keys. Asymmetric encryption, also known as public key encryption, uses a public key private key pairing. Data encrypted with the public key and only be decrypted with the primary key. TLS or SSL, the protocol that makes HTTPS possible, relies partially on asymmetric encryption, uh, HTTP and HTTP secure. That is what we call HTTPS. A client will obtain a website's public key from that website's TLS certificate or the SSL certificate and use that to initiate secure communication. The website keeps the private key secret. Okay. So, data encryption standard or the DES is a now outdated. I have mentioned four encryption algorithms here. So, in that, data encryption standard, or the DES, is sort of a outdated symmetric encryption algorithm. You use the same key to encrypt and decrypt a message. DES uses a 56-bit encryption key, uh, and it encrypts data in blocks of 64 bits. So these sizes are typically not large enough for today's users. Therefore, other encryption algorithms have succeeded DES. Triple DES, that's another one, was once the standard symmetric algorithm. Uh, Triple DES employ three individual uh, keys with 56 bits each. The total key length adds 56 into 3, that means up to 168 bits. But according to the most experts, its effective key strength is only 112 bits. And then we have RSA, a popular public key asymmetric encryption algorithm. It uses a pair of keys, the public key used to encrypt the message and the private key used to decrypt the message. And then we have Blowfish. It's a symmetric cipher that splits messages into blocks of 64 bits and encrypts them one at a time. So Blowfish is a legacy algorithm which is still effective. Okay, here's the process of symmetric encryption and decryption. Symmetric encryption is a data encryption model that works with just one key for encrypting, or as encoding, and then decrypting as decoding. Uh, it's a popular encryption option, and the secret key used here can either be a mix of letters, words, or numbers. Uh, I mean, it looks like a gibberish characters. For it to work, both the recipient and sender must know the private key to use for encoding and decoding data. So it works by encrypting plain text, then converting it to ciphertext with the help of an encryption algorithm and private keys. The ciphertext can then be converted again to plain text with the help of the private key that was used to encrypt it with the decryption algorithms. So, symmetric cryptography is widely used in secure data stored in hard drives, archives, computers, flash drives, and laptops. So, these are data that are not involved in the active movement from network to network or device to device. So to protect such data, you can encrypt all the confidential files before storing them, or encrypt the entire storage device. So let's now see what symmetric algorithm is used for. While symmetric encryption is an older method of encryption, it is faster and more efficient than symmetric encryption, which takes a toll on networks due to performance issues with data size and heavy CPU use. So, due to the better performance and faster speed of symmetric encryption, compared to asymmetric, symmetric cryptography is typically used for bulk encryption, encrypting large amounts of data, for example, for database encryption. So, in the case of a database, the secret key might only be available to the database itself to encrypt or decrypt. So, industry standard symmetric encryption is also less vulnerable to advances in quantum computing compared to the current standards for symmetric algorithms. So some examples of where symmetric cryptography is used are payment applications like many online banking and payment applications require the verification of personally identifiable information before proceeding with their transaction. So it helps in predicting the correct information to prevent fraudulent activities and cybercrime, securing cybercrime yes, issues, and then securing data at rest. When a website or organization stores personal information regarding the users or the company itself, it is protected using symmetric encryption. This is done to prevent all kinds of snooping from either outside hackers or disgruntled employees inside the office. So looking to steal crucial information. SSL handshake, symmetric encryption plays a significant uh, role in verifying website server authenticity, exchanging the necessary encryption keys required, and generating a session using those keys to ensure maximum security instead of the rather insecure HTTP website format. Okay, so asymmetric encryption is an encryption model that requires two keys. For an example, key A and key B. It works in such a way that the information that key A can encrypt while key B can decrypt. So usually these keys can be used interchangeably such that if you use key A to encrypt data, you can use key B to decrypt this information. And if you use key B to encrypt information, you can decrypt the same information using key A. So this is however not fundamental in asymmetric encryption. So now if you wish to use asymmetric encryption, you will have to create a pair of machine keys. So after that, you will make the encryption key public and the decryption key private. Hence, the name public key and cryptography and private key cryptography. So you can then sign private messages by encrypting them using the public keys. So this is important because it ensures that only the intended recipients with the matching private keys of the message can see them and not by a interceptor. Asymmetric encryption is used when data is in transit to be stored in a remote storage like cloud storage or a database in a data center, as well as when retrieving data from data storage to applications. Encrypting the data prevents any hacker from intercepting the data and understanding what's in there while the data travels through the internet. For two parties to successfully communicate with each other using asymmetric encryption, there needs to be two key pairs. The party that sends the data always encrypt using the public key of the receiver, but they must uh, never encrypt the data using their secret key. So, what is asymmetric algorithms used for? Asymmetric key cryptography has found use in many authentication domains thanks to its thorough identity verification process. Some applications such as digital signatures, where verification of documents, origin, and signature authenticity is possible today thanks to asymmetric key cryptography, TSL or the SSL handshake. Asymmetric key cryptography plays a significant role in verifying website server authenticity, exchanging the necessary encryption keys required, and generating a session using those keys to ensure maximum security. So instead of the rather insecure HTTP website format, cryptocurrency, asymmetric key cryptography uses blockchain technology to authorize cryptocurrency transactions and maintain the integrity of its decentralized architecture. And key sharing, this cryptography category can also be used to exchange secret keys for symmetric encryption, since keeping such keys private is of utmost importance in its system. So, what is RSA encryption? RSA encryption is an asymmetric encryption algorithm named after its founders, uh, Rives, Shamir, and Edelman, that uses a block cipher methodology to encrypt data. So it has been adopted worldwide in many industries like VPNs, chat applications, browser authorizations, and email encryption. Like those are name few examples. So RSA algorithm is also used for the signing of documents where the sender can sign a document using his own private key and the receiver verifies the document using the sender's public key. So, since both keys are mathematically linked, it is impossible to replace either of the keys with the fraudulent piece. Now, let's move on to section 13.5.3, where we talk about certificate based encryption. Certificate based encryption is a system in which a certificate authority uses ID based cryptography to produce certificate. So this system gives the users both implicit and explicit certification. The certificate can be used as conventional certificate for signatures, but also implicitly for the purpose of encryption. We learned earlier that if we are to use either symmetric or symmetric encryption with another party, we need to exchange the keys. So, how are we going to do this practically? If the parties we want to communicate are living all around the world and we get new parties to communicate every time, so manual key exchange will make a lot of time and effort. So, this is what the certificate based encryption and the public and private key infrastructure came into existence. Public key certificate is based on certificate based encryption. It is also known as the public key infrastructure PKI and is a cryptographic approach that uses digital certificates to secure communication, verify identities, and establish trust between parties in a networked environment. So it combines the concepts of asymmetric encryption and digital certificates to provide a comprehensive security framework. There are four main elements in the PKI setup. The first is a digital certificate. These are small digital files that enable identity and encryption for a variety of use cases on the internet. So each certificate contains a wealth of identifying information about the organization or the entity it's issued to. So depending on the validation level it's issued with, but has a finite lifespan. So common digital certificate categories include SSL or TLS certificates. So these certificates are what make the secure padlock icons appear in your website's visitors browsers, and the not secure warning disappear. SSL certificates comes with three validations level: domain validation, organization validation, and extended validation. So, code signing certificates. These digital certificates help you secure your supply chain for software updates and offer users assurance that your software is legitimate and hasn't been tampered with. Code signing certificates come with one of two validations levels, standard or extended validation, and the latter makes Windows defend the smart screen warning disappear because they make your software automatically trusted by Windows operating systems and browsers. Document signing certificates, so these digital certificates use cryptographic functions, hashing, and digital signatures allows you to prove to users that your document is legitimate and hasn't been altered. So since you signed it, and email signing certificates. These digital certificates, also known as SMIME certificates, provide end-to-end encryption by encrypting your email content and attachments prior to them leaving your inbox. Email signing certificates also provide digital identity by allowing you to digitally sign your messages so that your recipients can verify that the information hasn't been altered and that it was actually you who sent it. Client authentication certificates. These digital certificates enable password-less authentication on your internal network. What this means is that authorized users can log in securely and verify their identities without having to remember or type in a cumbersome password and complete multi-factor authentication. The second element in is public-private private cryptographic key pairs. So these are the cryptographic tools you need to encrypt public key and decrypt private key information over the internet. The third element is certification authorities. One of the key components of any PKI architecture is a certification authority, or what's more commonly called a certificate authority, or CA. An organization can rely on one or more CAs within its PKI. When people think of the CA, they traditionally think of it in a sense of a root CA or an issuing CA. However, there are also intermediate CAs as well, certification authorities. Remember that public certification authorities are the identification card issuers of the internet. So they are kind of like the identity card issuers for your state or country of residence. For an example, in the United States, each state has its own equivalent of a Department of Motor Vehicles. We call it as DMV, which is responsible for issuing driver's licenses. So these licenses are government issued cards that you can use to prove your identity to drive, buy alcohol, get a job, and perform other business and tasks. So when you apply for your driver's license, in addition to having to pass a driver's test, you're also required to provide different types of official documents that prove your identity. So this includes everything from social security cards and both certificates, and like yeah, the cards and also the birth certificate to green cards and various proofs of residence. So once you verify your information with a third party, in this case, the DMV worker then takes your picture, which displays on the card along with your official signature. They then print the card with holographic markings that indicate your card is real and it's not a realistic forgery. Uh, so think of this like a digital signature. You can then use this. Okay. So here's the PKI architecture. Uh, it's in actually in a PKI setup, there are four main elements. The first is the digital certificate. These are small digital files that enable identity and encryption for a variety of use cases on the internet. So each certificate contains a wealth of identifying information about the organization or entity it's used to. Then we have SSL certificates. So these certificates are what makes the secure padlock icons appear in your website, visitors, browsers, and the not secure warnings disappear. So SSL certificates come with three validation level options: domain validation, organization validation, and extended validation. So let's see how the PKI architecture works. Number one, entity submits CSR, the certificate signing request to PRA, registration authority. The registration authority or RA is responsible for verifying the identity of entities applying for a digital certificates. So this can include checking proof of identity or other credentials. The RA doesn't issue certificates itself but serves as a trusted agent for CA. So RA will call you or email you to verify your application details. And then number two, RA sends ID approval to CA. CA is the certificate authority. After RA is confident about the identity of entity that is applying for a certificate, the RA will employ many mechanisms to identify uh, or rather verify your ID and claim, and once approved it is sent to certificates authority to issue certificates. Then number three, certificates authority sends certificates to PA, the verification authority. The CA creates a certificate with what RA sent and send the certificate to the verification authorities. They are partnered with yeah, to the authorities that they are like partnered with. And then under number four, CS sends keys back to the requesting entity simultaneously. They will send you the public and private key pairs too for you to install on your servers or tools that need PKI configured. And then number five, keys signatures are sent or installed on a server or website. The key signature is installed by you into your servers, websites, and tools. And then number six, keys are sent to the VA for verification. And then number seven, verification approval is returned confirming the authenticity of the key signature. There onwards when a user browses your website, for an example, over HTTP, the public key will be sent to the user's browser, which in turn use it to connect with the VA to find out whether your server or website is the correct one or fake site. The VA will process the public key received with their registered keys and certificates. An illustration of what happens when your request when you request an SSL or TSS certificate for your website, and the role of the certificates authority, the CA, plays in the process. So as you can see in the illustration, it starts with you requesting an SSL or TLS certificate for your domain from a public certificates authority. So before the certificates authority can issue the cert, they first need to verify your identity and that you also control the domain in question. So they might call you, email you, and have a few conversations before they are certain that you are a genuine company or an individual that needs a certificate. So once they do this, they can then issue your certificate. So, which they apply their digital signature to prove that they issued it. So, once you have the certificate, you can then install it on your web server. So, this allows you to verify your identity and to establish secure encrypted communication channels with site users, browsers. So in the PKI architecture, once a certificates authority issues a certificate, it's the responsibility of the VA to always validate each and every request for validation by users. The VA maintains a valid certification list and expired certificate list and revoked certificates list. So CA issues a certificate for a specified period, usually for a year. Therefore, the certificates expire. It is the responsibility of the party that's brought the certificate to renew the certificate by applying for a new one. So further, sometimes certificates gets revoked even during the validity period for situations such as business shutting down operations or selling the service to another owner. So the responsibility of the VA is to verify that the certificates is still valid and its authenticity by checking that the certificate is issued by a trusted certificates authority, CA. So checking if it's still valid, checking if the certificates has been revoked. Remember our DMV example, Department of Motor Traffic. So the CA is like the DMV issuing the ID, and the VAs like the traffic police. They check whether you have a valid ID and verify you. Right, so now it's time to discuss a past paper question related to the lesson. I've selected a question number three in the 2023 June, the summer past paper. The section A of it reads as uh, encryption is used to protect data that's being transmitted over the internet. One type of encryption relies on a certificate. A certificate includes general items such as the date of issue, So give one general item found in a certificate. So I have added a screen capture of a certificate here so we can see the non-general information on a certificate. They include the name of the issuing authority, the type of certificates issued, its version, serial number, digital signature of the issuer, name of the owner, and expiry date. So your answer can be any one of these and you will score 1 mark. The second section of question 3A asks us to describe the role of a certificate authority in the use of certificates based encryption. Okay, the second section of question 3 asks us to describe the role of a certificates authority in the use of certificates based encryption. Okay, so there are a few key roles certificate authorities play. Number one, a certificate authority is an organization that issues the certificate. Number two, a certificate authority maintains a list of certificates that have been issued. Number three is to help establish trust between communicating entities over the internet. So that is someone wants to communicate with another will trust the CA and its certificate details than the other party. So of course the CA cannot just blindly issue certificates to anyone. The certificate authority verifies that the entity business registering the certificates is who they say they are. If they don't do that, the trust on the CA will be lost by others. So this is their fourth role. Final role is a certificate authority maintains a list of certificates that have been revoked, expired. So these are certificates expired or cancelled and no longer valid. You need to write at least two of the five roles. So moving on to part B of the questions, here we are expected to complete a diagram of the steps of encrypting messages to be exchanged. A partially drawn diagram like this one was provided in the question paper and you are expected to fill the diagram correctly. Remember, as per the question, Alice uses symmetric key encryption to send her messages while Bob uses I'm sorry, I will also read through the question. Okay, so symmetric and asymmetric are two types of encryption. Alice sends a message to Bob using symmetric encryption, but Bob sends a message to Alice using asymmetric encryption. Complete the diagram to show the steps required for the messages to be exchanged. You must include plain text, ciphertext, and types of keys. Right, okay. Now we go again to the right. A partially drawn diagram like this one was provided on the question paper, right? And you are expected to fill the diagram correctly. So remember, as per the question, Alice uses a symmetric key encryption to send her messages, while Bob uses a symmetric key encryption to send his messages. So therefore, the way the encryption and decryption works in the two parts are different. Yeah, it's a must, right? To get the correct set of marks. Right. Okay. So with that, we conclude this lesson and also the question that we took from 2023 paper question 3. So this concludes the topic 13 as well. We covered topic 13 in 5 lessons. So I will add the playlist here so that you can go through the full topic 13 in the order. So we will see you soon with another lesson. Until then, thank you and good luck with your studies.